Can this new enzyme turn back the clock in bodily tissues? That's the question driving a new study published July 16 in Nature Communications. Scientists have long known that the same chemical reaction that browns a cake also ages our cells. Over decades, sugars in the bloodstream react with proteins and fats, creating compounds called advanced glycation end products, or AGEs. These AGEs accumulate like rust on long-lived tissues such as collagen, making them stiff, sticky and inflamed, which contributes to heart disease, eye damage, kidney disease and diabetes. For years researchers tried to block AGE formation with drugs, but those efforts have had absolutely no success. Now a team led by Aaron Cravens, founder and chief executive of Rebel Pharmaceuticals, has taken a different approach. Instead of preventing AGEs, they built an enzyme that can actually remove one of the most common AGEs from human tissue after it has already formed. The work began with a simple hypothesis: because all human tissue eventually returns to the biosphere after death, nature must have a way to break down these extremely durable compounds. To find that natural cleanup crew, the researchers turned to microbes, the agents of decomposition. They used artificial intelligence to analyze the DNA sequences of more than 50,000 microbes, predicting the three-dimensional structures of the enzymes each genome could produce. From that massive screen they identified a candidate enzyme that could target a specific AGE known as glucospane. In laboratory tests, the enzyme cleared glucospane from collagen and other proteins isolated from real human tissue, restoring some of the tissue's youthful flexibility and reducing inflammatory signals. Cravens calls it a small step in a very complicated field, but notes it is the first time anyone has shown at the structural level that such reversal is possible. Retired biochemist John Baines, who spent his career studying AGEs at the University of South Carolina, described the finding as a tour de force of modern biochemical and molecular techniques, emphasizing that demonstrating activity on real proteins from real tissue is excellent work. While the enzyme is still far from clinical use, the study opens a new avenue, targeting the extracellular matrix itself, not just cellular aging, to potentially treat a range of age-related diseases. That's the latest from the front lines of aging research. Thanks for listening, and we'll catch you next time.